This video explains the short-term serviceability load deflection calculations using the IG. So basically we calculated the deflection at A in the previous video. That calculation was given here, which is 0.39 millimeters, where our beam start cracking. Now in these examples, now we say that okay, the beam is loaded up to serviceability load. Okay, so the load coming on to this beam is not the load which allows this kind of theoretical concept. That is not actually we are just finding the point where it's going to start cracking. So that point we found it. Now we say that okay, the beam will loaded to the serviceability load, which is WS. At this particular point, what would be the deflections that we want to find? So the service load that can be found by adding the dead load plus live load, but please note the live load will be multiplied by these short-term factors. We are calculating the short-term deflections, so we're going to find the short-term serviceability load. We are not multiplying the load factors here, let's say 1.2 and 1.5 here. This is for serviceability, not for the strength limit state design. This is for serviceability limit state matters. Now in this case, the dead load is given in our examples, which is 30 kilonewton per meters, that is given here, plus the short term factors given 0.7, that substitute here, times 20, that is live load, equal to 44 kilonewton per meter. So we found the service load WS was 44 kilonewton per meter. Now at this service load, what is the deflection? So this W is actually this 44 kilonewton per meter. So if this W is 44 kilonewton per meter, now this maximum deflection at the midpoint would be 5 WL to the power 4, 384 ECI. So at this particular point, if you just 5 times the service load is 44, that service load is 44 times 7,000, that's the length of the span that is given in the questions, 7 meters, also given here 7,000 millimeter span, over 384 EC. I think EC we calculated in the last video, where you calculate this EC, Young modulus of the concrete, from table 3.1.2, that is for 25 megapascals. From that tables we found that value. Now once you found this EC 26700 gross IG, that is the gross moment of inertia, that we also found from the previous video, 1 times 10 raised to power 10. If you substitute that value, you will get 5.15 millimeters. So it's actually saying that at this particular point where you apply the service load, your deflection in the beam at this particular point is 5.15 millimeter. Please note, at this particular point the beam is beam has this deflection 5.15 millimeter at the service load. In the next video, we're going to calculate the deflection at this particular point B2. Thank you very much.